Hello everyone. Welcome to Gurudev Academy. I am Dr. Sridhar, a Neet faculty. Today I am in live streaming based on a Neet 2025 chemistry paper 7 discussion. Okay. Yes, dear all, please come to the first question, that is question number 46. Why the size of anion is larger than that of parent atom? See, why the size of the anion is larger than that of a parent atom. So we need to solve the problem with a very easy manner. See, as electron is added, then as a result it will become negative charge. As the negative charge takes place because of the addition of one electron. Because of the addition of one electron, the electron repulsion is increases. Yes, due to the increase the repulsion of among the electron. Yes, this is the right statement. As the electron repulsion is increases, then size is also increases. As a result, effective nuclear charges decreases. Yes, due to the decreasing in the effective nuclear charge. Of course, this point is also right. Due to the increasing in effective nuclear charge, no. Then both 1 and 2, yes, both 1 and 2 are right answer for the question. Well, go to the next. Match the column 1 with column 2. So column 1 they given delta H, delta S and delta G value with respect to column 2. See, delta H is negative, delta S is negative and delta G is also negative. Enthalpy, entropy and Gibbs free energy, all three are negative. Then that indicates the reaction will show spontaneous at lower in temperature. Hence the A, it shows for A the right answer is R. Reaction will show spontaneous at low temperature. Well, if we come for the B, delta H is positive, delta H is positive, delta S is also negative. I'll repeat one second. Delta H is negative, delta S is negative, delta G is positive. If delta G is positive and delta H, delta S are negative, then reaction will be a non-spontaneous at a high temperature. Then the reaction will be non-spontaneous at high temperature. Then it will shows for B, it will shows P. Next, delta H is positive, delta S is positive and delta G is also positive. If all are positive, then it will shows the non-spontaneous at lower temperature. Yes, so option C, okay, Nandiya, the C it is related to the Q. So reaction will non-spontaneous at low temperature. At last, the delta H is positive, delta S is positive, delta G is negative. It will shows the remaining at least reaction will show spontaneous at a high temperature. Then which is the right answer for this question? For A corresponds to R, A corresponds to R, then B corresponds to P, nothing but as this one, C corresponds to Q. Yes, option 2 is the right answer for the question. Well, go to the next. At the state of dynamic equilibrium for solute and solvent is equilibrium with solution. So when the solute and solvent is equilibrium with solution, what this concept relates? The rate of dissolution is equal to rate of saturation? No, it is not a dissolution. It is a what? Dissolution here. The rate of dissolution is equal to what? Rate of unsaturation. Yes, here the both answers are same. The rate of dissolution is equal to rate of saturation. Then ultimately I will go for rate of crystallization is equal to rate of saturation. So which is the right answer here? As the solute is goes on dissolution, then saturation is goes on increases. At stage of equilibrium, okay na, as the reversible takes place, then unsaturation takes place. And okay na, here the both options are right here. The rate of dissolution is equal to rate of unsaturation. So here I can say that and both are correct here because both statements are same here. Well, go to the next. The formation of CO and CO2 illustrate the which law? See, when C plus of O2, when carbon is reacts with of O2 is giving rise to carbon monoxide, And for the preparation of carbon dioxide, C plus O2 is giving rise to carbon dioxide. See, carbon dioxide and carbon monoxides are formed with a combination of carbon and oxygen. Here, the product which are formed by forming one of the mass of an element is fixed. That carbon mass is fixed, but differ in the masses of the oxygen. Then this concept was explained by the law, that is law of multiple proportion, and the right answer is the C. Okay, so when two different elements are combined together to form two or more than two compounds, in which one of the element having a fixed mass with another element having different masses. Well, go to the next. Assertion: the resistivity for the substance is its resistance when it is 1 meter long and its area of cross section is 1 square meter. See, what is resistivity? The resistivity is equal to, or is directly proportional to the L by A. So, resistivity of the substance is the resistance, means R is proportional to its 1 length meter, that is L, and area of cross section. So, I can ultimately write that R is equal to rho into L by A. So, assertion is correct. Then reason: the SI unit of resistivity is ohm meter. Yes, of course, the SI unit of resistor is ohm per meter. That is right answer. Of course, the assertion and the reason both are correct, but the thing is, reason is the not correct explanation for the assertion. Okay, hence the reason is not correct explanation. Nothing but as option 1 is the right answer for the question. Go to the question number 51. Statement 1. The geometry of the amine is pyramidal. See, if you write the amine structure, that is RNH2. That is what? I can take it as what? RNH2. So, if you write the structure of the amine, nitrogen is present at the center, then it is bonded with water, 3 hydrogens, one alkyl group, another was 2 hydrogens with lone pair of electron. Here, because of the presence of the lone pair of electron, there is a repulsion between the lone pair and bond pair. Okay, now the geometry will be shows pyramidal in a geometry. Yes, the statement 1 is the right statement. Next, the angle CNC or CNH is slightly more than that of 119.5 degrees Celsius. Actually, carbon nitrogen carbon bond angle is less than the 109.5 degrees Celsius. Here they given more than that. That's what statement 2 is wrong, and statement 1 is correct, statement 2 is incorrect. So option C is the right answer for the question here. Well, dear students, go to the next question. Mark the oxide which is amphoteric in character. Among the 4 options, which is amphoteric in nature? Let's come to the solution. Carbon dioxide and here SiO2. These two are acidic in nature. SnO2, tin oxide, it is amphoteric in nature. And at last, calcium oxide, it is basic in nature. So I need only a amphoteric character, and option 3, that is SnO2, is amphoteric in nature. Well, go to the next. The correct IUPAC name of, here PT, NH3 taken twice, Cl2 bracket, square bracket. Here there are 2 ligands, that is one is amines, another is what? Chlorido. Here alphabetically A come first, that's what? There are 2 amines are there, then I can write it as what? Diamino. Then dichlorido. Here there are 2 ligands are over, then remaining platinum. Okay, now so directly I can write it as a platinum. Here the oxidation state of the platinum, here ammonia is having 0 and Cl is -1, 2 into -1 -2, then it become what? +2. Then I can say that platinum 2 in bracket. So which is the right answer here? Diamine dichlorido platinum. Option 1 is the right answer for the question here. Go to the next problem then. The equilibrium constant for the reversible reaction. Yes, they given N2 plus 3H2 gives equilibrium with NH3 is K. So anyhow, for the reaction and of N2 plus 3 by 2 H2 equilibrium with NH3, the equilibrium constant K dash. So what they ask here, the K and K dash will be related. The relation between the K and the K dash they are asking. This is one of the very simple concept. First I will take the equation 1, that is K. Look at it guys, N2 plus 3H2 is equilibrium with what? NH3. This one I can take it as K, equilibrium constant K. Write the K value for this one, equilibrium constant. Then K is equal to product divided by reactant. What is the product here? NH3. How many are there? Only one is there. Okay. Sorry, I did not balance this one. For balancing purpose, I will take 2 NH3. Yeah, of course, they are given here. Then write the equilibrium constant K is equal to what? NH3 whole to the power of 2 divided by, there is a 1 nitrogen whole to the power of 1, and there are 3 hydrogens are there, that is H2 whole to the power 3. So this is considered equation number 1. Now I will go for the equation 2, that is K dash. For K dash, that reaction will be, that is of N2 plus 3 by 2 H2 is equilibrium with what? NH3. This is I will consider as K2. This is I will consider as what? K2. So now write the equilibrium constant K2 is equal to product divided by reactant. How many product? NH3. There is only one molecule is there. NH3 whole to the power of 1 divided by, here N2 of N2 will be there. So I will write as N2 whole to the power of into hydrogen, that is H2 whole to the power of what? 3 by 2. So this is I will consider as equation number 1. Sorry, equation number 2. Now dividing the equation 1 by 2. Then here you can take here amines are 2, here amines are 1, here N nitrogen is 1, here nitrogen is off, and here hydrogens are 3, but here hydrogens are 3 by 2. So here if I make a square root for the K, then it will become what? K dash. So which I am simplifying, K dash is equal to square root of K. For the K, if you make square root, then K dash is equal to square root of K, it will become balance and equal. So the relation is K dash is equal to square root of K. Hence, that is answer 3 is the right answer for the question. Well, dear students, I will go for the next question. In quantitative analysis, NH4 is added before NH4OH. I will repeat once again. In qualitative analysis, ammonium chloride is added before ammonium hydroxide. Why? When ammonium chloride, that is NH4Cl and NaOH, among these one, which one is common? NH4 is common due to the common ion effect. Okay, it will decreases the water OH minus ion. So decreases the concentration of the OH minus ion. That's the reason why ammonium chloride is added before the water NH4OH. Well, go to the next problem then. Which of the following is not permissible arrangement of an electron in an atom? So this is a question based on the quantum numbers. If n is equal to 5, then L is equal to 3. If L is equal to 3, then M it may be minus 3 to plus 3. So M0 is here and S is plus of, okay, of course it can form. Go to the next one. If n is equal to 3, then L is equal to 2. If L is equal to 2, then M is equal to minus 2, minus 1, 0, plus 1 and plus 2. But here they given M is equal to 3. Okay, na? If L is equal to 2, then M cannot be a minus 3. Hence, this is not permissible for the arrangement of electrons. Hence, the right answer for the question is option 2. Well, move to the next. Assertion. The rate of reaction is the rate of change of concentration of the reactant or product. Yes, the statement is right. As the reactions takes place, the concentration of the reactant is decreases and simultaneously concentration of the product is goes on increases. Okay, so the assertion is right and correct. Go to the reason. The rate of reaction remains constant during the course of the reaction. During the course of the reaction, rate of reaction will never be a constant. It is always get changes. Hence, assertion is correct, reason is incorrect. Okay. Well, which is the right answer for that one? Yeah. Yeah, option 3, assertion is correct, but reason is incorrect. Option 3 is the right answer for the question. Dear students, go to the next problem. It's a very simple concept. Identify the correct IUPAC name of the compound. Dear all, they given the structure here. For this one, we need to write the IUPAC nomenclature. Look at here, this is an aldehyde group and this is a benzene group. Here, according to the rule, first I will give for the preference for the functional group for the numbering. If you do numbering here, 1, 2, 3, 4, 5 and 6. Then here I can find the two substituent, that is one is the benzene and another one is a phenyl here. Then I can write that is number 5, that is a methyl 4 phenyl. Where it is that one? Yes, 5 methyl 4 phenyl. Then there are 6 carbon atoms are there. Then eggs, all are having single bond, that is AN. Then there is an aldehyde group, aldehyde suffix as AL, this is AL. So 5 methyl 4 phenyl hexanol. Option 4 is the right answer for the question here. Well dear, so go to the next problem then. The commercially carboxylic acids are reduced to alcohols by converting them to. See, commercially carboxylic acids are reduced to alcohol. So which components I can take it here? Yes. Among these one, I can get the carboxylic acid and reduced to alcohol by converting them by, that is ester. Because when esters are undergo acid hydrolysis, then the bond is undergo breakdown here. Then H is added this side and OH is added this side. Ultimately, we are going to get the new molecule. A new molecule like this and another one, resulting in the formation of RC double bond OH. I am going to get it as a formula, that is RC double bond OH. That is carboxylic acid and R dash OH, that is alcohol and carboxylic acid. I can get it. So the right answer for this question is first one, that is esters. Well, go to the next problem then. Dear all, which one of the following gives only one monochloro derivative? Among these one, okay, option, which is the molecule when it is undergo chlorination, which molecule is undergo monochlorination? Mean only one chlorination takes place. Yes, N-hexane that is 6 carbon atoms which are linked together in a long chain. Here it never be a monochlorination. N-methyl pentane, here also not possible because the 5 carbon atoms it is present in the form of long chain. 2,2 dimethyl pentane, here of course here also it cannot take place of monochlorination because of the out of 5 carbon atom, okay, now 2 carbon atoms are bonded with 2 methyl, but remaining 3 carbon will be free, no? So even though they undergo more than monochlorination. At last, neopentane. Yes, of course, the neopentane is an undergo monochlorination. So why it is undergo monochlorination? We should know the structure of the neopentane. That is, one carbon is bonded with the surrounding methyl group. Okay, such a molecule structures are called as neopentane. In this neopentane, the carbon surrounded all 4 groups are what? Same structure. That's CH3. Wherever the monochlorination takes place, the structure will become what? Same. Hence here the monochlorination takes place only for the what? Neopentane here. The right answer is 4. Well, go to the next. The reagent which does not react with both acetone and benzaldehyde. Which one will not undergo react with both acetone and benzaldehyde? Here, acetone and benzaldehyde. So usually among these sodium hydrogen sulfide, phenyl hydrazine, Fehling solution and Grignard reagent, this Fehling solution is a weak oxidizing agent. It is a weak oxidizing agent. Which one is the Fehling solution? Because of the weak oxidizing agent, okay, it cannot oxidizes the benzaldehyde because of the benzene ring. Okay, because of the benzene ring, Fehling solution become a weak oxidizing agent. So it cannot oxidizes the benzaldehyde because of the benzene structure. Because of the benzene structure, it cannot oxidizes. And moreover, acetone, it is a containing ketone. Ketone will not respond for this one. So hence, okay, now the reagent does not react with both acetone and benzoyl. It is what a Fehling solution, because the reason is Fehling solution is a weak oxidizing agent. That's it. Well, go to the next. The common oxidation state of the titanium. So we know that the titanium is, okay, na, it's a D block element. It comes to a 3D series. So first element is scandium, the second one is titanium. Titanium atomic number is 22. If you write the electronic configuration, that is 3D2 and 4s2. Then if you remove the one electron, so we can't remove the one electron, because if you remove one electron, then s orbital having only one electron. That's what it is impossible to remove one electron. Directly you can remove two electrons. If you remove two electrons, then it can show Ti plus 2. If you remove 3 electrons, 2 from here, 1 from here, then it can show Ti plus 3. If you remove 4 electrons, here 2 and here 2 you can remove, then by removing the 4 electrons, it can 4 plus 4. Like this, titanium it can 4, 2 electron, 2 plus 2 plus 3 and plus 4. So plus 2 plus 3 plus 4 are the oxidation state of the titanium, and the right answer is the 4. Well, go to the next problem then. So, which of the following molecule exist? Which of the following molecule exist? So, among the 4 options, that is helium. So, helium 2 molecule, its bond order is, bond order is 0. So, it cannot exhibit as a molecule. Next, Be2. Okay, now Be2 molecule, even its bond order is also 0. Hence, it cannot also exhibit the water molecule. Go to the next. Li2, lithium. So, lithium it can exist a molecule because its bond order is 1. If the bond order is 1, then it exhibits the molecule 2. Means there is a single bond between the lithium and lithium. Hence, option 3 can exhibit the molecule. So, option 3 is the right answer for the question. Well, dear all, go to the next. Statement 1. Denaturation leads to the conversion of globular protein into the fibrous protein. Yes, of course, the statement is absolutely correct and right. So, how can I explain this one? It's a very simple. I will take a simple one example by taking a egg white. So, egg white is a globular protein. Okay, it is a what? Jelly nature. When you boil it, then it becomes hard, because on heating a globular protein is converted into what? Fibrous protein. Okay, egg white on boiling it becomes solid, nothing but as the conversion of globular protein into what? Fibrous protein. Statement 1 is correct. Next, go to the statement 2. Denaturation after primary structure which gets distorted. They are saying after the denaturation, primary structure will get destroyed. Actually, during the process of the denaturation, secondary and tertiary structures are get destroyed, not primary. Okay, I'll repeat once again. During the denaturation protein, secondary and tertiary proteins are get destroyed, but not primary. But they given here primary structures are destroyed. So statement 2 is incorrect. Statement 1 is correct, and the right answer is 3, because statement 1 is correct. Statement 2 is incorrect. Okay. Yes. Go to the next problem then. Question number 65. The two compounds, that is benzoyl alcohol and benzoic acids, are formed a compounds when it is heated in the presence of NaOH. This compound is, see, by which compound reacting with NaOH, it will give benzoyl alcohol and benzoic acid. So it is one of the very easiest concept to understand. Benzoyl alcohol and that benzoic acid. Just I'll write the structure, this one. This is the water, benzoyl alcohol, that is benzene CH2OH, and benzoic acid. So these are the structure I can get it from when the compound react with NaOH. Then what is the compound? The compound which do not containing alpha hydrogen react with NaOH gives these two product. That name of the reaction is called as Cannizzaro reaction. That name of the reaction is a Cannizzaro reaction. Cannizzaro reaction. Then what is Cannizzaro reaction? When benzaldehyde, okay na, so benzaldehyde is a molecule which do not containing alpha hydrogen, which do not contain alpha hydrogen. So benzaldehyde do not contain alpha hydrogen. When it react with sodium hydroxide, then it forms what? Benzyl alcohol along with the formation of the, okay na, sodium benzoate, which is further undergo acidification. Then obviously we can get as what? Benzoic acid. Hence here the benzaldehyde is the molecule undergo Cannizzaro reaction to use the product. Hence option 1 is the right answer for the question. Well, go to the next. What is the amount of heat in joules absorbed? So they are asking the what amount of heat is absorbed, that is Q is equal to how much they are asking. So what is the amount of heat absorbed by 18 grams of water? So 18 grams of water. Initially at the room temperature heated to 100 degrees Celsius. 18 grams of water heated at 100 degrees Celsius. Next, if 10 grams of copper is added to this water, for the same 18 grams of water, they added 10 grams of copper, they added. The decreasing in the temperature in the Kelvin, the temperature is goes on decreases. The decreasing in the temperature of the water was found to be how much? That is T2, we need to find out. For water, they given that is CPM. Yeah, the CPM for the water they given 75.32 joule per mole per Kelvin they given. Yes, anyhow, the CP for copper is 24.47 joules per mole Kelvin. See what need to be identified here. So we need to identify first Q. If we calculate the Q, then directly we can get the answer. Yes, dear all. So what is the formula we need to, first I will write 8 grams of water. Okay, now at 100 degrees Celsius. 100 degree nothing but as what? 373 Kelvin. For this solution, if they add 10 grams of copper added. When 10 grams of copper added, then temperature is changes to what? Approximately near to room temperature, that is of 25 degrees Celsius. Its value in terms of Kelvin 298 Kelvin. Then they asked to calculate to Q. Then what is Q? Then Q is equal to Cp into air, okay, along with the delta T, the change in temperature. Cp they given here, how much they given? 75.32. 75.32 they given into mass, that is how much they given here? 18 gram. 18 gram divided by what? Molecular mass is 18 into the dt. dt means change in temperature. Change in temperature means final minus initial. The final is how much here? That is 373 Kelvin minus 298 Kelvin. So here we need to do simplification. Then after this multiplication and division, I am going to get it as 5649. Okay, now I am going to get 5649. I am going to get, this is the Q value. If the Q value is same, then obviously the T2 value will become how much here? 369. That is 369. Hence the answer A is the right answer for the question here. Well, go to the next problem then. Yes, the structure is reacted with PCC, then it will give the A. Then A will show that A will react with reagent. Okay, anyhow, I will take this one. So it's very simple. When this molecule is treated with PCC, we know that PCC means pyridinium chlorochromate. Pyridinium chlorochromate is a complex structure which oxidizes only secondary alcohols, Among these, this is a secondary alcohol and this is the tertiary alcohol. Here PCC oxidizes only secondary alcohol, so resulting in the formation, I am going to get this molecule. Okay, so like this I can retain the product as A. that A product will undergo reacts with what? In this structure, we can remaining only a tertiary functional alcohol will be there along with ketone will be there. Bromine water test, tolerance test, vector Mayer's test and Lucas test. We know that Lucas test is easily oxidizes the tertiary alcohol. So that's the reason why tertiary alcohols easily undergo react with what? Lucas reagent. That's what a tertiary alcohol react with Lucas reagent. It will give turbidity immediately. Hence, the fourth option is the right answer for the question. Well, dear all, go to the next problem then. The pK of weak acid HA is 4.80. They given the pK value. Just I am going to write the datas here. If you write the datas like this, then it is very easy to solve the problem. Okay, na that pK they given, the pK of weak acid HA is, that is a 4.80. Next, the pKb of weak base BOH is, that is pKb is how much? 4.78 they given, and pH of an aqueous solution corresponding to the salt, they are asking the pH is equal to what? See, we can solve this problem very easily because pH of aqueous solution of salt they are asking. For that one, pH is equal to half into pKw plus pKa minus pKb. This is a formula we can use to solve this problem. So substitute the value. pH is equal to half into pKw. We know that the pKw value of the water is, that is how much? 14 plus pK value already given here, that is what? 4.80 minus pKb value is how much? That is 4.78. Okay, so first we need to add this one, then we need to do subtract this one. After that we can make into divided by with 2, which is on simplification. I can get the value that is 7.01. Okay, so the 7.01 where I can find here? In option 3 I can find. Hence option 3 is the right answer for the question here. Well, dear, I'll go to the next question number 69. Which of the following statement regarding properties of the halogens are correct? So we need to, which is the option, which is the statements are correct? We need to find that one. Well, read the first question. First one, due to the small size, electron gain enthalpy of the fluorine is less than that of chlorine. Yes, the statement is absolutely correct. So due to the electron gain enthalpy, the smaller size of the fluorine, electron gain enthalpy is less. Of course, I can say Cl as greater than the fluorine regarding about the electron gain enthalpy. Yes, that first statement is right. Go to the next. Iodine as same physical state but differ in color as compared to the other member of the group. See, other member of the group nothing but as the fluorine, chlorine, bromine, iodine. These are all the other member group of the iodine here. They says that they are same in physical property. No, absolutely it's wrong. Okay, na? Fluorine is a gas, chlorine gas, bromine liquid, iodine is solid. How come it be? So statement 2 is incorrect. Go to the third one. Fluorine shows no positive oxidation state. Yes, of course, obviously it's the right statement. Fluorine, it can never be as a plus charge. Only chlorine, bromine, iodine, they can form the plus charges, but fluorine never can be a positive oxidation state because of the more electronegativity. This third point is also right. In X2 plus H2O gives HX and HOX. So here X2 or Cl or bromine. Yes, of course, it can also form HX and HOX. That's last one. F2 is the strong oxidizing halogen. Obviously, it is a strong oxidizing halogen. Hence, first, third, fourth, fifth. First, third, fourth, fifth are correct statement. Only second is incorrect statement. Well, dear all, go to the next problem then. Pyruvic acid is obtained by. First, we should know what is pyruvic acid. Then we can come for how can we obtain. So pyruvic acid nothing but as CH3, C double bond O, COOH. This is called as what? Pyruvic acid. Then how can I get this pyruvic acid? Yes, this pyruvic acid can be get it by the when aldehyde reacted with hydrogen cyanide. Here what happens here? Oxygen is negative charge, carbon is plus charge. H is plus charge, Cn is minus charge. This H attacks here, this Cn minus attacks here, this double bond is undergo breakdown. So resulting in the formation of CS3, COH and C triple bond N it forms. Okay. So this is an oxidation of acetaldehyde with the cyanohydrin. Okay, so second option is the right answer for the question here. Still, I will continue the reaction. When this molecule is further undergo addition of water in the presence of acid, in which nitrile undergo acid hydrolysis gives what? Carboxylic acid. Gives what? Carboxylic acid. That is CS3, COH, COOH. Like this, it gives a carboxylic acid. When this molecule is further is an undergo oxidation, so resulting in the formation of what? Pyruvic acid. Okay, so like this, pyruvic acid I can obtained by the oxidation of acetaldehyde cyanohydrin. Well, go to the next problem then. The IUPAC name of the compound having formula. So this is the compound. I need to write the IUPAC nomenclature. It's a very simple OH, NH2 and carboxylic acid. There are three types of functional groups are there, in which carboxylic acid is the main primary functional group and remaining all are I can consider as what? Substituent. Yes, I will numbering from here 1, 2 and 3. For the second carbon there is amino, for third carbon there is an hydroxy. So 2 amino, 3 hydroxy. 2 amino, 3 hydroxy, 3 carbon atom, that is a prop. In between carbon there is a single bond AN. Here there is a carboxylic acid functional group OIC. So 2 amino, 3 hydroxy propanoic acid is the right answer for the question. Well dear, I'll go to the next then. Yeah, please. Assertion. 1-chlorobutane on heating with the alcoholic KOH undergoes dehydrohalogenation to yield 1-butene as a major product. See, here this is a what? Dehydrohalogenation takes place, means it is undergo elimination reaction. I will write the 1-chlorobutane, so CH3, CH2, CH2, C butane nothing but as CH2Cl. Okay, when this molecule is treated with the alcoholic KOH, so this hydrogen I will write here. When it undergo when this molecule is undergo react with alcoholic KOH, it's very simple. This K combined with this Cl resulting in the formation of minus KCl, and this OH combined with this H resulting in the formation of minus H2O. Ultimately, there is a formation of double bond here. Then I can get is CH3, CH2, CH double bond, CH2. Like this I can get 1-butene I can get. Yes, of course, that 1-butene I can get. That assertion is correct. Well, go to the next. What is the reason? The reaction does not occur through the carbocation. The reaction does not occur through the carbocation intermediate, but instead occurs by the concentrated mechanism. Yes, of course, the reason is also correct. Hence, both reason and assertion is correct, and reason is the correct explanation for the assertion. So answer A is one is the right answer for the question. Go to the next problem then. Problem number 73. Bohr's model can. So what Bohr's model explain? So Bohr's model explain solar spectrum? No. Spectrum of hydrogen molecule? No. It did not explain for only hydrogen molecule. So Bohr's explained the spectrum of any atom or ions containing only one electron. Yes, of course, that Bohr's explained the spectrum for the atoms or molecules which containing only one electron. So answer 3 is the right answer for the question. Well, go to the next then. The correct structure of FeCO taken 5 is. So we need to write the structure. So Fe is the iron is the central metal atom. Then it is bonded with the 5 carbonyl groups. Out of 5 carbonyl groups, 3 carbonyl groups which are present at the 3 corners here. Okay, na? So resulting in the formation of the trigonal. Resulting in the formation of what here? Like this, a trigonal. And another 2 more carbonyl groups. One is present above the plane, another is present below the plane. Okay, na? So here it forms like a pyramid. Here it forms like what? A pyramid here. Okay. Well, So like this, it forms like this, it forms the trigonal bipyramidal. It forms what? A trigonal bipyramidal it forms here. Answer 4 is the right answer for the question here. Well, go to the next. If Kc is in the range of dash, appreciable for the concentration of both reactants and product, what should be the Kc value to appreciable, to balance the concentration of the reactant and the product? To balance the concentration of the reactant and product, that both sides the Kc value should be what? Same. That means of negative and positive values should be same. So among this one I can say, among this one 10 to the power of minus 3 to the 10 to the power of 3. Both sides the charges are same, 10 to the power minus 3 and 10 to the power plus 3. So then only the concentration of the reactants and products are managed or appreciable. So the right answer for the question is second. Well, go to the next problem then. The vapor pressure of benzene at 30 degrees Celsius. So T is equal to how much? 30 degrees Celsius is 121.8 mm of Hg. So vapor pressure of benzene, usually benzene is taken as a solvent, it's a pure component, that's what I taken as a P0A. How much it is? 121.8 mm of Hg it is given. When 15 grams of non-volatile solute is dissolved in 250 grams of benzene. So non-volatile solute nothing but as weight, WB, weight of the solute, that is how much? 15 grams. Dissolved in 250 grams of benzene. Benzene is a solvent, that is a WA. How much? 250 gram they given. How much they given? 250 gram. Well, when 15 grams of non-volatile solute dissolved in 250 grams of benzene, then vapor pressure of decreases. Means when solute is added to the solvent, it will become solution. Then vapor pressure of the solution is decreases. How much it is? 120. That is P is equal to how much? 120.2 mm of Hg. The molecular weight of the solute is how much? Molecular weight of the solute nothing but as what? MB is equal to how much? And in the bracket they given molar weight of the solvent, that is what? MA. MA they given how much? 78 gram they given. So we need to calculate the molecular mass of the solute. So this question is based on the formula of relative lowering of vapor pressure. Then I can write that is a P naught A minus P divided by P naught A is equal to given weight of the solute divided by molecular weight of the solute into molecular mass of the solvent divided by weight of the solvent. So just I will substitute the value. P naught is how much? That is 121 point minus 120.2 divided by 121.8 is equal to weight of the solute 15 gram, yes, given, divided by its molecular mass. We need to calculate what? MB into what is MA? MA value 78 divided by WA. WA is given 250. So now you just to subtract this one, 121.8 minus 120.2. I can get is 1.6 divided by 121.8 is equal to 15 divided by MB into 78 divided by 250. Just I will cross and rearrange. Take this 1.6 here and 121.8 upside and take the MB here. So MB is equal to 15 into 78 into this one I will take upper side. So 121.8 divided by 1.6 into 250. So which is on simplification, I can get MB is equal to, on multiplication and division, I will get the 356.2 grams I will get. So the right answer 1 is the correct for this question. Okay. Well, dear students, go to the next problem then. Question number 77. The long form of periodic table consisting of. So they are asking here how many number of periods and how many number of groups. Yes, we know that the periodic table containing what? 7 periods and 18 groups ends. Okay, na? 7 periods and 18 groups ends. Answer 2 is the right answer for the question here. Well, dear, go to the next. The oxidation number of the hydrogen in hydrogen iodide, calcium hydride and lithium hydride respectively. So we know that general statement, in metal hydrides, oxidation state of hydrogen is -1. Here the sodium hydride is a metal hydride, so hydrogen oxidation state is -1. Calcium hydride, that here also it is also metal hydride, here hydrogen oxidation state is -1. Even lithium hydride is also a metallic hydride, here also hydrogen oxidation state is -1. So in all cases oxidation of hydrogen is -1, and option 4 is the right answer for the question. Well dear, go to the next. The coordination number of a central metal atom in a complex is determined by. So coordination number of the central metal atom is, if the metal is present at the center, then how many number of ligands are approaches to the center, that will be the what? Coordination number. So let's go for the solution here. The number of ligands surrounded a metal ion bonded by a single bond and a pi bond. The number of ligands surrounded by a metal, no, it never, there is a wrong statement here, okay na? So the metals are surrounded by ligand, but ligands are not surrounded by metal. Option 1 is wrong. Go to the next. The number of ligands around a metal ion bonded by a pi bond. No, there is no pi bond between the ligand and metal. Even second statement is also wrong. The number of ligands surrounded a metal ion bonded by a sigma bond. It's right. Already I explained here that metal, it is present at the center, which are surrounded by the ligand by the coordination bond. Okay, now here they given sigma bond. Yes, the option 3 is the right answer for the question here. Well, go to the next one. Assertion: benzoyl methyl ether on reacting with dilute and cold hydrogen iodide produces the methyl iodide. So I'll write a reaction. Benzoyl phenyl ether, nothing but as what? Yes, this is the water benzoyl, and this is the water methyl. Ether, nothing but as, between this one there is oxygen. This is the structure of the benzoyl methyl ether. When this one is treated with the dilute and cold hydrogen iodide, it is retreated with the cold dilute and cold hydrogen iodide. We know that hydrogen is always positive charge and iodine is always negative charge, and in ether oxygen containing a lone pair of electrons. Okay, here what happens here? This lone pair of electron donate electron to the water hydrogen here. So resulting in the formation of an intermediate like this. It forms an intermediate. Oxygen, it make a bond with the hydrogen, and oxygen carries the positive charge here. So now what happens here? Here whatever the iodide H minus will be there, no, it attack to the methyl, and this methyl group donate electron to the again oxygen. So resulting in the formation of what? Methyl iodide, along with formation of the benzoyl alcohol, benzoyl alcohol. Hence the assertion is the right statement. The reason: this reaction occurs via SN2 pathway. No, it never takes place as SN2. Okay, so here assertion is correct and the reason is incorrect. Okay, na? So option 3 is the right answer for the question here. Well, dear students, go to the next problem then. The brown ring test for NO2 and NO3 minus 1 due to the formation of complex. So which complex is formed here? So just I'll write the reaction, simple reaction. When HNO3 nothing but as, when it is dissociated, H plus and NO3 minus 1. Okay, like this. When this HNO3 reacted with H2SO4 in the presence of the FeSO4. So resulting in the formation of Fe2SO4 taken twice, it forms with formation of NO and H2O forms here. So here there's a liberation of NO is most important, because when nitrate treated with sulfuric acid, the brown ring gas is produced due to the formation of NO. Next, this NO further it is undergo reacted with ferrous sulfate with water molecule, so resulting in the formation of the complex Due to the formation of the complex, it forms the brown ring. Okay, now what is the complex? Fe H2O taken 5 NO all to the power Fe plus 2. Of course, there is a SO4 minus ion is also formed here. So because of the formation of this complex, it forms the what? A brown ring. Hence, the right answer is the 3 for the question here. Well, dear, go to the next. Question number 82. The conversion of PHCN to PHCOCS3 can be achieved most convenient by the which reaction? Yes, I can convert it from phenyl cyanide to the water, this one. See, it's a very simple PHC triple bond N. Okay, now that phenyl nitrile. When this phenyl nitrile is an undergo treated with the first, I will try with first reactant, that is CH3MgBr, that is what as Grignard reagent. We know that in this Grignard reagent, magnesium is always positive in charge and methyl is always in negative charge. And also we know that in nitriles, carbon is having carries a plus charge and nitrogen carries a negative charge. So here, when the reaction takes place, the opposite charges are attract. This plus 1 will attack to the minus, and minus plus 1 will attack to minus, minus 1 will attack to plus 1. So CS3 minus attack to C plus, and Mg plus attack to what? C minus, resulting in the formation of, that is a PHC double bond N. This carbon is attacked by what? CH3, and this nitrogen is attacked by MgBr. Next, this molecule is further undergo hydrolysis. This molecule is further undergo hydrolysis. Yes, they given CS3 MgBr followed by hydrolysis. So when they are undergo hydrolysis, addition of water. It's a very simple. They are all. Just take a look here. When you add a water molecule, OH goes to here and H goes to here. Here, that O goes to here and H2 goes to here. So resulting in the formation of 3 different molecules I can find here, that is PHCOCH3, PHCOCH3 I can find here. This is a one molecule, and I can find another molecule N, 2H and 3. Totally it forms NH3 along with formation of MgBrOH. MgBrOH. See, I can get the expected product what they given here. Hence, answer 1 is the right answer for the question here. Well, go to the next problem then. Choose the correct option for the following reactions. Yes, of course, they given the reactant molecule. Okay, when this reactant molecule is reacted with Hg, okay, mercuric diacetate in the presence of water with sodium borohydride. Actually, addition of water takes place in the presence of this one Hg mercuric diacetate. So what happens here? Actually, the product what I am showing here, that carbon is surrounded with water, 3 methyl groups here along with the CH double bond CH. When it undergo addition of water in the presence of this one, it undergo Markovnich's rule. It follows the water Markovnich's rule, resulting in the formation of addition of OH takes place to the secondary carbon and addition of hydrogen takes place for the primary carbon. So resulting in the formation of the Markovnich's rule it follows. Then for this one, when this molecule is undergo treated with the diborane in the presence of hydrogen peroxide and OH, addition of water molecule, addition of OH, that means addition of water molecule takes place by following the anti-Markovnich's rule. By following the anti-Markovnich's rule, ultimately I can get is what? CH3C, I can write CH3, CH3CH, then CH2OH. The OH bonded to the primary carbon atom and H bonded to the secondary carbon atom, means it follows anti-Markovnich's rule. So ultimately I can write A product formed by the following Markovnich's rule and B product formed by the anti-Markovnich's rule. So which is the right answer? A is Markovnich product, B is anti-Markovnich's rule. So option 2 is the right answer for the question. Well, go to the next one. When aniline is treated with the HNO3 and H2SO4, nothing but as nitration takes place. So component A, component B and component C is produced. Consider the given reaction, the percentage yield. Actually, when aniline is undergo treated with the nitration HNO3 in the presence of H2SO4. NO2 group is electron donating group. Usually, preferably, we can get para should be more. Para should be a more. Here the para will be there. That is a 51% I can get. That is 51% I can get. Next, ortho will be less. But this phenol, this aniline, when it is treated, because of the presence of the concentrated H2SO4 here, it forms anilinium ion. It forms what? Anilinium ion. This anilinium ion acts as electron withdrawing group. Because of the it acts as electron withdrawing group, it will prefer for the meta position. It will prefer for the nitration for meta position instead of ortho. So here the meta positionally nitration will takes place more. That's what meta position will takes place about 49 or 48% will be takes place. The remaining 2% or 1% will be a ortho. So that is the reason why C is greater than B is C is more, B is less, A is very less. Hence, which is the right answer? Yes. Option 1 is the right answer. Para will be more, meta will be little more less, and ortho will be very less. Well, go to the next problem then. Question number 85. For the given reaction, they given Sn plus 2 electron gives Sn, Sn plus 4 electrons gives Sn. The electrode potential for the E naught of Sn plus 2 bar Sn is minus 0.14, and E naught value for Sn plus 4 bar Sn is 0.010 volt. The magnitude of standard electrode potential for Sn plus 4 bar Sn plus 2 is, so we need to find the E naught for this magnitude. Okay, we should keep the value in terms of 10 to the power of minus 2 volt electrovolt. So this concept can be solved very easily. Okay, now just I will apply some techniques and rules. Just follow here. So first I will write this reaction Sn plus 2. By taking the 2 electron, it will form Sn. The E naught value for this one, yes, of course they given. The E naught value for Sn bar Sn2, that is how much here? Minus 0.140. Okay, for that one I can write here delta G is equal to minus NF E naught cell they given. I will take this one. For this equation, I can write the delta G value, that is delta G is equal to minus, what is the number of N electrons? Minus 2 into what is F? F I will keep it as it is. Okay, now what is the E naught value? That is minus 0.140. Just to substitute the value and simplify, minus into minus here, plus that is 0.280 F. Now go to the next reaction, Sn plus 4, here they given, by taking the 4 electrons, it will give Sn. Now write the delta G value for this one. Delta G is equal to minus, how many electrons are there here? 4 electrons are there. Minus 4 into fluorine into, what is the E naught value? E naught value, of course they given. E naught for Sn plus 4 bar Sn is, that is how much? That is 0.010 volts. Just do the simplification. Then delta I can write is G1. Okay, na? I can write for G2. Okay, na? Yes. So G2 will be how much? Minus into minus here. I can get the minus just I'll do multiplication 0.040 F. So these are the values of G1 and G2. So we should remember the value of this one and we should remember the value of this one. Okay. So now I will go for the delta G3. So for which component they asked here? They calculate the standard electrode potential for Sn plus 4 bar Sn plus 2. So Sn plus 4, by gaining the 2 electrons, it will become Sn plus 2. Okay, so we need to calculate for this one delta G3. Delta G3 is equal to minus, how many electrons are there here? 2 are there, into fluorine as it is. Okay, and also we need to calculate the E naught cell for Sn plus 4 bar Sn plus 2. We need to calculate this one. So we need to calculate how, on following which method? So just you make the delta G03 is equal to delta G01 2 minus delta G01. Just substitute the value and do the calculation. Just I will substitute delta G nothing but as how much here? That is minus 2 into F into what? E naught. That is Sn plus 4 bar Sn plus 2 is equal to delta G2 nothing but as this is a value. So minus 0.040. I'll write one more time. Minus 0.040 fluorine. Okay, minus of. What is G1? So value of G1 is this one, 0.2 0.280 fluorine. Now you do the simplification, multiply the minus here, minus 0.040 minus, what it is there, minus 0.280. Now take the minus common here, minus and you take the F common here, that is 0.40 plus 0.280. So here this fluorine get cancelled. Take this minus on this side, minus 2, minus will get cancelled. Minus will get cancelled. By addition and by dividing with 2, I can get E naught of Sn plus 4 bar Sn plus 2 is equal to 16 I will get. So I will get it as, 0.16 I will get. So 0.16 on shifting the decimal I can get 16 into 10 to the power of minus 2 I will get it here. So which is the right answer for this one? Yes, of course, answer 3, that is 16 into 10 to the power of minus 2 I will get it as a result here. Well, go to the next problem then. Arrange the following carbocations in decreasing order of their stability. So we need to arrange the carbocations in decreasing order of stability. Among these one, which one is more stable? Yes, among these one, this is allylic carbocation, this is vinylic, this is tertiary methyl, this is tertiary phenyl, and this is what a carbocation is bonded with the cyclic structure. Dear all, here because of that CS2 carbocation is bonded with the trimethyl cyclic compound, it is more stable. The most stable component is fifth one. Next, the next stabilities go for the triphenyl because the carbocation is bonded with the 3-methyl group. Because of the 3-phenyl group, it is more stable. So then second place goes to fourth one. Then among first, second and third, the third place goes to for allylic. Allylic will follows the third placement. Then fourth placement among these vinylic and tertiary carbocation. So the fourth place goes to what? Trimethyl carbocation, and the least will go for what? The vinylic. Then which is the right answer for that fourth? Fifth win will have highest. Then second place goes to fourth one. Then third place goes to first one, then fourth place goes to third one, the least will be second. Hence option 3 is the right answer for the question here. Well, dear, go to the next. Match the column 1 with column 2. See, the compound formed when yellow CrO4, that is a chromate. When chromate is acidified, just I written CrO4 minus 2. CrO4 minus 2, when it is an undergo acidification, it is forms a dichromate, Cr2O7 minus 2. Chromate anion undergo acidification to become dichromate. Yes, of course, for A it is Q here. Next, reagent oxidizes Fe plus 2, Fe plus 3. So, in reaction we are doing in the practical titration, when acidified KMnO4 treated with the ferrous sulfate, then it becomes ferric. Yes, of course, that B belongs to what? P. Next, when compound produces when MnO2 is fused with KNO3. This is the method we are going to use for preparation of what? KMnO4. So, your first K2MnO4 is formed here. The last, compound having dark purple crystal isostructural KCl4. KCl4 nothing but as it is isostructural with what? KMnO4. So because KClO4. This is a KCl4. here I can write Cl, double bond O, double bond O, double bond O, here OK. And also I can write as MnO4, KMnO4, Mn, double bond O, double bond O, double bond O, OK. See, KCl4 isostructural what? KMnO4. Hence, D is belongs to what? S. Just I will find the right answer for A, Q, for A, Q, for B, P, for C, R, for D, yes, yes. Option A is the right answer for the question. Go to the next problem. KMnO4 react with oxalic acid. Yes, of course, they given reaction here. When MnO4 minus 1 react with oxalic acid in the presence of H plus gives Mn plus 2 CO2 and water. See, hence 50 ml of 0.04 KMnO4 is acidic medium is chemically equivalent to. So 50 ml of 0.04 KMnO4 they will give. For this equivalent weight we need to calculate for the oxalic acid. Yes, of course, in the answer they given oxalic acid. So equivalent weight of the chemical KMnO4 is exactly equal to equivalent weight of oxalic acid what? So I will solve this one. Equivalent weight of KMnO4 is equal to molecular mass divided by change in oxidation state. For the KMnO4 the oxidation state is 5. In the same way, equivalent weight of the oxalic acid H2C2O4, how much? Its molecular mass divided by, for one carbon there is a one change in oxidation state. For a 2 carbon, I can write as molecular mass is 2. Then I can solve that molar equivalent weight of KMnO4 is equal to how much they given? 50 ml they given into what is the change in oxidation state here? 5 into what is the concentration they given? That is 0.04. So which is on simplification I can get it is what? Answer 10. Then molar equivalent weight of oxalic acid. Molar equivalent weight of oxalic acid. Oxalic acid means H2C2O4 is equal to how much? See, if KMnO4 value, if molar equivalent is 10 means oxalic acid is also 10. Then what is the concentration here? Then 50 into. So even the oxalic acid also I will take the 50 ml and change in oxidation number is 2 into dash. Okay na? So I need to calculate the chemical equivalent weight of this oxalic acid, that is a concentration as well as volume. So now take this value as x. Then x is equal to 10 divided by 50 into 2, 100. So 10 divided by 100 nothing but as 0.1. So 50 ml of oxalic acid and 0.1 concentration among these one. Option 3, 50 ml of 0.1 molar oxalic acid. So answer 3 is the right answer for the question. Go to the question number 89. Which one of the following reaction does not represents the correct combination of the substrate and product under the given condition? Okay, let's go for the solution. Here, when benzene C-double-bond-O-Cl, when this molecule treated with the hydrogen supported with the palladium barium sulfate, okay na, that hydrogen supported palladium barium sulfate, it can easily reduces, that benzyl chloride converted into aldehyde. Yes, of course, this is the right statement. Next, when benzene bonded with CN, when it is treated with the DIBAL, this reagent reduces the asymmetry, and it oxidizes diisobutyl aluminum hydride, DIBAL. Diisobutyl aluminum hydride is a reagent. It reduces the most asymmetry or unsaturated component resulting in the aldehyde. Yes, of course, this is also correct. Next, when this benzene C-double bond ester, when esters are treated with what here? Aluminum hydride with tertiary butyl followed by hydrolysis, it gives aldehyde. Of course, it is also correct. The last one is this is a benzyl alcohol. When this is a benzyl alcohol, this is CH2 and OH. When benzyl alcohol are treated with the that is sodium dichromate Na2Cr2O7. They said that here they given a aldehyde. Actually, when benzyl alcohol treated with the sodium dichromate oxidizes the alcohol into aldehate, further undergo oxidation gives carboxylic acid. Actually here it will give carboxylic acid. But they said aldehyde, hence which one is does not represents correct means option 4 is the does not represents correct. Well, go to the last concept of this last question of this paper 7. Which of the following statement regarding fuel cell is incorrect? Regarding about the fuel cell, which one is incorrect, that we need to say. Dear all, first one, these cells are eco-friendly. Of course it is eco-friendly because it does not give any harmful chemicals or any gaseous. It's a right statement. These cells convert energy of combustion of a fuel like hydrogen, methane and methanol. Yes, of course, in the fuel cell we can use the hydrogen as a fuel or methane as a fuel. Of course, it's right. H2O2 fuel cell is used in Apollo space program. It's 100% in Apollo space that hydrogen oxygen fuel is used. Yes, it is one of the application. The last, fuel cells produces electricity with efficiency of 100%. Actually, it is a wrong statement. It will not give 100%. It will give 40 to 70% it will give. So, option 4 is the incorrect statement for this question. Okay. So, dear all these are all the components what I discussed are most important here. Okay. So, please watch this video and get the knowledge for this one. Okay. So, for more videos, okay, please subscribe the video. Okay. Thank you dear all. Thank you so much.